because again we're trying to revolve this region. And so if we're revolving this, I'm gonna have too many black lines. I'm gonna get rid of that for now. So if we're revolving this around y equals 2, so again I kind of just, you don't have to be a super good artist to do this. I'm kind of just drawing it exactly like the mirror image would be. It kind of looks like this and that. And then if I kind of create some circles around this, but notice with this problem, if you that this inside, if you were to kind of draw little circles, so this would be what it would look like for a hole. Notice that region that I was originally trying to, I'll kind of gently color this in with some yellow, almost like a highlighter. This was the region that I'm trying to revolve. So notice the gap here between that region and my axis of revolution. That's going to be our hole. So in setting this problem up, we're still doing volume by revolution, so we're still integrating the area of a circle, so we're still integrating pi r squared. And these are still, the width is still change of x, so this will still be a dx problem. But as I kind of spoiled already, this does in fact have a hole. So anytime your region, this yellow region, isn't up completely against my axis of revolution, you can kind of see there's a gap between the region and my axis and my y equals 2. So this will be a hole. And what that means is we need to essentially find the volume of the entire region. So a lot of times we capitalize that, use a capital R to represent the outer radius. And we want to subtract out the whole. So we want to subtract out the inner radius. And just like the last problem, you can factor out a pi. And so then we just have to do our outer radius squared minus then my inner radius squared. This will also be with respect, since we said dx. Because this is still with respect to x and it's still the same region, again my leftmost bound is 0, so it'll be my lower bound. My upper bound, my rightmost point, my rightmost x value is 4. What I would suggest doing is draw in your radii. So from this lower point here, so this will be my outer radius. It's going to be the entire distance. And then you can kind of see the inner radius would be what I have drawn here in blue. That'll be my inner radius. That'll be our hole. So the outer radius, no matter where we are on this interval from 0 to 4, so whether we're out here or here, or that red line I already got drawn in, the outer radius remains the same. That outer radius is what this distance 2. You can also think about looking at like your top function minus the bottom function to get that distance, and so the top function is y equals 2. The bottom function is that x-axis, which is y equals 0. Following the same idea with the inner radius of doing top minus bottom to represent that distance. So the top of, notice these blue radii, is going to be again y equals 2. The bottom is based off of this curve, that square root of x. And you might be asking yourself, like, so why in this problem do we do top minus bottom where we didn't in the last example? And so going back to that really quick too, if that is your question, notice your top function for this is the square root of x. The bottom of the function is y equals 0. So I mean, we could have put minus 0 to represent this distance, but subtracting 0 doesn't really change anything, and so that's why I didn't bother including that in the first problem. And you can kind of go about this the same way as the last problem, squaring them first and then integrating. But I mostly wanted to do a couple of examples to show you how to set up these integrals. I think that is what challenges most people as opposed to actually taking the antiderivative.